So now to another technique of integration, what is called integration by parts. And the purpose of this technique is to undo the product rule. I will admit this is very rare. Directly knowing the antiderivative, 95%. Substitution, 3%. Undoing product rules, like 1%. So this is rare. It's kind of, we try doing it directly, we try doing substitution, and then we'll try undoing the product rule. And you're going to be shown two methods for this. One that I call the formal method, which you have to know because sometimes it can only be done formally. And then in a different video, I will show you the table method, which is very, very fast, but can only sometimes be used. And then I'll have a third video that deals with special cases of integration by parts. So the idea of this is remembering that when we do product rule, we have this idea of, okay, I have first times second, and I take the derivative of the whole thing. Well, then I'm doing first times derivative second plus second times derivative first. And the idea is we undo the UV prime part and then worry about the VU prime part. That's why it's called by parts, is we're not undoing the entire product rule at once. We're undoing it piece at one part at a time. So the formal notation of this is we will decide what part should be called U and which part should be V, or dV. So our original integral we're going to say is U dV. Once we've identified those, we can then say, well, then that's going to give me U times V minus the integral of V du, where the integral of V du is hopefully an easier integral to evaluate. Kind of a way this goes, we want to choose U to be something that would eventually derive down to 0 if possible. That's not always possible, but it's nice if we can. We may have to do integration by parts multiple times. And then a source of confusion, the U that we're referring to here in the integration by parts is not the same thing as in U substitution, because we're undoing a different rule here. So the best way to do this is by examples. So I have the integral of x cosine of x with respect to x. First thing I do is, do I know any function that has this as its derivative? No, I do not. So then I think, well, what about substitution? Could this be a chain rule? Well, I don't see anything inside of anything else, because x is not inside of anything, cosine of x is not inside of anything. So it doesn't look like substitution is going to work. So that leaves me with integration by parts. For integration by parts, I need to pick a u, and I need to pick a dv. The u I want to be part of my integral that would derive down to 0 if possible. So I have the choice of x or cosine of x. X derives down towards 0, so I'm going to say that's u, which means everything else, including the dx, is my dv. For the u, I'm going to take its derivative. And then because the integral of u dv is equal to u times v minus the integral of v du, I need the du, so I'm going to solve this for du. But now with the dv, I need to know what v is. So I need to undo the dv, which means I want to take the integral. And if I do it on one side of the equation, I have to do it to the other. So there's a little 1 in here. So that gives me a v. The antiderivative of cosine would be sine. Just do a quick check. Derivative of sine is cosine. So yeah, I'm not going to worry about the plus c here. I'm going to save that for the end of my integration by parts work. So now I have u times v minus the integral of v du. So I now have part of my antiderivative, and I have an easier integral. So the x sine x isn't going anywhere. Then I have my minus. The antiderivative of sine would be negative cosine. And then my plus c because this is an indefinite integral. And there is my antiderivative. If I go to another example, here I have an integral of x squared e to the x. Do I know anything that has that as a derivative? No. I don't really see anything inside of anything else because it's x that's being squared, and I don't want to say that u is equal to x. For substitution, there's nothing, e to the x. Okay, so substitution, I don't see anything inside that would involve chain rule. So that leaves me with product rule. So I want the u to equal something that would derive down towards 0 eventually, which would be the x squared, because e to the x's derivative is itself, which means dv is equal to e to the x dx. What's left? I need the derivative of u, which is 2x, and then solve that for du. For dv, I need to undo the derivative part. So I get v equals e to the x. So I have u times v minus the integral of v du. So I now have part of my antiderivative and what I would hope would be an easier integral. But now when I'm looking at that integral, the integral of 2x e to the x, I don't know anything that has that as a derivative. I don't see anything inside that would involve chain rule. So it's still product rule. I'm going to have to do integration by parts again, but on the easier integral. So I'm going to say u is equal to 2x, find its derivative, and solve for du. Everything else is dv. Take the integral to get rid of the derivative. So I have v is equal to e to the x again. So the x squared e to the x is still there. I have minus, then I need to remember I'm subtracting everything I'm doing here. The new u times the new v minus the integral of v du. So I still have an integral left, but it's now one I can do. So I've got x squared e to the x from my first integration by parts minus the quantity 2x e to the x minus 2e to the x plus c. And here is my antiderivative. I can even do this with being asked to find a particular solution. So if I'm given the differential equation dy dx is equal to x ln of x, and it passes through 1, negative 1, and I want to find out what's y. In other words, I need the function. Well, I have a separable differential equation, so dy is equal to x natural log of x dx. I need to take the integral to undo the antiderivatives. So y is equal to the integral of x times the natural log of x dx. I don't know anything that has the derivative x natural log of x. I don't see anything inside, so chain rule doesn't look like it's used, so that leaves me with undoing product rule. So I'm going to say that u is equal to the x, and dv is equal to the ln of x dx. So du dx is equal to 1, du equals dx. Integrate my dv, so I get v is equal to, uh-oh, that didn't work at all. So the integral of the natural log of x, I don't know. So let me try something different. Let's say that u is equal to the natural log of x then. and dv is the x dx part then. So I now can figure out the v, but now du dx is 1 over x, which means I have 1 over x dx for my du. So taking all of this here, I have that y is equal to u times v, 1 half x squared, times the natural log of x, minus the integral of v du, which would be 1 half x dx. That's much better. So this is a case where u isn't necessarily always going to be the term that derives eventually down to 0. So y equals 1 half x squared times the natural log of x minus 1/4 x squared plus c. But then they tell me it has to go through 1, negative 1. So negative 1 equals 1 half times 1 squared times the natural log of 1 is 0, minus 1/4 plus c. So c is negative 3/4. So that means that y is equal to 1 half x squared times the natural log of x minus 1/4 x squared minus 3/4.